Hi, my name is Sam Shuey from Maple Systems. In today's lesson, I will show you how to use the counter functions that are readily available as part of ladder logic instructions in the Mapware 7000 programming software for the HMC 7000 series products. These include counter and the up-down counter. In our last video on timers, we saw that timers are used in ladder logic programming to determine when a predefined amount of time has elapsed. Counters are very similar in operation to timers, but instead of counting to a preset length of time, counters are used to determine when a specific number of events have occurred. Counters are widely used in many industrial control systems. For example, think of how a counter might be used in a bottling plant. After the bottles are filled, sealed, and labeled on an assembly line, you may wish to package these bottles in boxes for shipment. A counter could be used to count how many bottles are placed into each package before the package is ready to be sealed and sent to the next station. The Mapware 7000 software supports two counter functions that can be used in ladder logic. The counter, which increments while the enable input is on, and when the count input contact transitions from the off state to the on state. When the preset count value is reached, the counter stops incrementing and the output turns on. Setting the enable input off resets the counter to 0 and also turns the output off. The up-down counter increments or decrements depending upon the current state of the up-down input contact. If the contact is in the off state, then the counter decrements the count. When this contact is on, the counter increments. For the counter to be active, the enable input must be on. Then the counter will count up or down for every ladder logic scan as long as the count input is on. When the counter is active, the output turns on. Setting the enable input to off resets the counter to 0 and also turns the output off. Please note that the maximum value that a counter can count to is 65,535 counts. Now let's implement some counters using block 1 in the main logic block folder and two screens that will demonstrate the operation of the counters. Notice that in rung 1 we have created a counter using C0. You will also notice that instead of using a constant value for the preset register, we have decided to use an internal data register of D0. By doing this, we can adjust the number of counts that the counter will increment before it reaches the preset value and turns on the output coil. Although we chose to use a data register to store the preset value, you can easily select a constant value for the preset register or a register address using the instruction properties box for the selected counter. To get the counter to increment, we will use the internal bit coil B0 for the count bit and B1 for the enable bit. The output contact is set to B2. On run number 2, you will see an up-down counter. The up-down counter requires three inputs: the enable input, the count input, and the up-down input. Notice that we have placed a rising edge contact before the count input of the up-down counter. This is to ensure that the count only occurs with each transition of the state of the B4 coil rather than whenever the ladder logic program is scanned. Note that this counter does not use a preset value. The up-down counter simply continues to count until reset using the enable bit. Although the output coil is on while the counter is active, it will shut off when the counter is disabled. Before we leave this ladder logic block, notice that we never use the same counter address twice. Once you have associated a particular counter address with a counter instruction, you cannot use it again for another counter. Also note that the counter instruction requires 2 lines and the up-down counter instruction requires 3 lines. You must allocate enough lines in your ladder logic program to accommodate the requirements of each instruction. Otherwise, an error message, overlapping of instructions not allowed, may appear when you try to place a counter instruction into your ladder block. To see how these counters work, let's create two screens to demonstrate each counter. Screen number 1 demonstrates the operation of the counter in rung number 1. The counter is ready to go when the B1 enable toggle bit is pressed. Register D0 is used to place a preset value, and we will monitor the counter C0 as it counts. The counter increments whenever the B0 count momentary bit is pressed. The output, B2, should turn on once counter C0 reaches the value in preset D0. We want the counter to increment 5 times, so in the task folder for screen number 1, we will preload D0 with 5 whenever this screen opens. Screen number 2 demonstrates the operation of the up-down counter in rung number 2. The counter increments if B3 is on, decrements if B3 is off. The enable bit, B5, must be on for the counter to be active. Because we are using a momentary button, B4, for the count bit, and since we are using a rising edge in the ladder logic for this input, the counter will only count when B4 button is pressed. Notice that as soon as this counter begins counting, the output bit, B6, turns immediately on. The output bit remains on until the counter is reset to 0 by shutting off the B5 enable bit. Now let's download this project to the HMC 7057 unit and see how the counters work in action. The startup screen is screen number 1, which has been pre-configured with a preset count in D0 of 5. Let's turn on B1 to enable the counter. Then let's press the momentary switch B0. The counter increments with every press of the button. Notice that output B2 turns on once the preset count has been reached. To reset the counter, we simply turn B1 off. Since we are using a preset register for the count value instead of a constant value, we can easily change the preset count so that the counter increments to a new constant. Now let's look at the up-down counter on screen number 2. The up-down counter, shown on the screen number 2, uses the B3 toggle button to determine whether or not the counter will increment or decrement the count. When B3 is on, the counter increments. When B3 is off, the counter decrements the count. We have already set B3 to be on, so that it will start incrementing once we have activated the count input. Now let's turn on B5 to enable the counter. Then let's press the momentary switch B4. The counter increments with every press of the button. Notice that output B6 turns on immediately after the counter starts counting. Let's press the B3 button to change the direction of the count. Now, when we press the B4 button, it causes the counter to decrement. To reset the counter back to 0, we simply turn B5 off. Note that the output contact B6 turns off when we disable the counter. This completes our video on how to use the two counters that are available as ladder logic instructions for the HMC 7000 series. Please consult the Mapware 7000 help files and the HMC 7000 series operations manual for more details on these and other features of the HMC 7000, or visit our website at www.maplesystems.com for more video tutorials, specifications, and other helpful materials on the HMC 7000 series.